advances in Prrs research there. And prior to that, he was a swine practitioner in Morris, Minnesota. So I'd like to welcome Dr. D.
Well, thanks a million, Marlis. It's really an honor to be selected for this webinar. I've never done one of these before, so I'm very excited about this new technology, and I'm hoping that we get a lot of questions and discussion from our participants. And I'm really honored that your periodical has requested my services today. And again, as you did, I'd like to thank BI for the support for so many years in the Prrs arena. They've been leading. And I have, as you said, been working with this disease now for it's about 40% of my life. Began in practice in West Central Minnesota, kind of grew up with Prrs as it came out of the mystery swine disease stages, and went into a PhD actually at the University of Minnesota to become a better swine practitioner in order to battle this disease. It was just devouring my clients. And well, after 12 years in practice, I realized there were some issues with transmission and biosecurity that we didn't understand, and so I left practice and went to the faculty at the University of Minnesota, specifically to work on those issues. How does the virus move around, and how do we stop it? And after 12 wonderful years at the school, I had accomplished my goals, and I wanted to take our discoveries and test and validate them on a larger scale into a very collaborative pork production system that works closely with veterinarians and producers, and that's the reason I looked to Pipestone for an opportunity for the next phase of my career, and I'm having a wonderful time there. And it's a great group, and it's been fun to be back on a pig farm every day. So with that, I think I'll begin and talk a little bit about science-based biosecurity using Prrs as a model. Okay, so before we begin, I think it's important to disclose as well as thank the many groups that have supported my research efforts over the 20-some years I've been involved in this disease. And the slide shows you a long list of key individuals and companies and organizations, beginning with research support from the USDA Prrs Cap 1 and 2. Credit to Mike Murtaugh and Bob Rowland, who directed those efforts. The National Pork Board and our own Minnesota Pork Board, those funding entities have been the mainstays for the work we've done. So a lot of credit to those groups. Now, when I was at the university, we organized a group called the Swine Disease Eradication Center, or the SDEC, and this group has supported us as well. And in particular, for the topic today, I'm going to recognize 3 southern Minnesota practices that I had a chance to work very closely with at the school. And one, Pipestone, Dr. Gordon Spronk; another, Swine Vet Center, Dr. Darwin Reichs; and then Fairmont Veterinary Clinic, Dr. Paul Ruin. And so these individuals and their teams have been pioneers, basically, in the area of Prrs virus biosecurity and specifically air filtration. So they need a lot of credit. This is truly a team effort. Dr. Steve Pohl, he's an engineer, as you may know, from the South Dakota State University, an ag engineer. He deserves a lot of credit because he's the one who puts a lot of these filtration systems together and makes sure there's sufficient ventilation for the animals under filtration. And finally, 2 wonderful grad student scientists who are now successful veterinarians in their own right. They studied under me, Dr. Satoshi Otake, who did a PhD, and Dr. Andrea Pitkin, who's with the Fairmont Veterinary Clinic at this time, did her master's, really are the ones that carried the weight and did all the pioneering efforts and the research aspect of filtration. So Andrea and Satoshi deserve a great deal of credit. And if there's questions I can't answer, I might refer the question to them. So they're the best. And finally, to disclose, during my complete tenure at the university and also currently at Pipestone, we have no monetary ties with the sales of filtration equipment, no patents, no financial tie whatsoever. I think we're more interested in the science than we are in the monetary. So that's important for everybody to know. All right. So background information aside, and the cards are on the table, let's talk about what we're going to talk about today. Number 1 topic, the importance of Prrs. Just a very brief overview of what it can do, what its cost. Number 2, how does it spread and how do we stop it? Some basic research we did at the school. And then also some research from our Pipestone group in regards to the role of slurry or pit pumping as a way to spread the virus. Some of our updates on air filtration that I'm still continuing to work with the other clinics as well. And then some kind of fun research projects we did looking at commonly asked PRRS questions. I think the audience will enjoy these updates. It's pretty much right up to today, so it's real-time information. And then we'll close. All right. Well, this one isn't a surprise. It's a familiar sight for any pork producer who deals with this disease. And, you know, this is an animal welfare issue. It's a human welfare issue. It's an economic issue. We all know the importance of PRRS. We all suffer. Producers do not like this disease. They don't like to see their animals suffer. And it's very costly. You know, easily on a 3,000 sow farm, you're going to spend at least $500,000, if not more, on a PRRS outbreak. And you look at post-weaning, there's all sorts of estimates of the cost of the weaned pig all the way from weaning to market, from $625 to $1525 per pig. And a recent publication to be from Dr. Darrell Holkamp, National Pork Board funded, it looks like we're over $600 million of cost per year to our U.S. industry. So this disease is extremely costly and is very, very devastating to the producers and the animals. So if we're going to talk about control and potentially elimination, and there's been a great focus on area regional control elimination, if we're going to be successful, we have to know how this thing spreads, and we have to know how to stop it. So what I'd like to do is take you through a study that Andrea Pitkin led in her first year of her graduate program, and then Satoshi Otake took over for the next 3 years. But Andrea's work was really the pioneering work. She published the first paper, and she used this picture, this model, I'll call it a production region model that you can see on your slide, as a way to understand how the virus spreads between farms and how to stop it. And what this diagram shows you are basically 4 buildings at our Swine Disease Eradication Center research farm in west central Minnesota. Now, there's no other pig farms for 10 miles from this place, and so it's a very isolated area where we could actually bring in negative animals, bring in live agents, infect animals experimentally, and understand how things really work in the real world. So these 4 buildings are to represent a neighborhood of pork production. 4 producers in close proximity to one another, just like we'd have in some of the very dense regions of our country. And you can see in the middle there that the source population building, that's the barn where, in this case, we brought in 300 head of nursery through grow finish pigs, and we infected them experimentally with a virus called PRRS virus Minnesota 184. That's a virus that we had in previous work shown had the ability to spread via the aerosol route. And then around this source population, we put 3 other buildings to represent 3 other producers. And basically, we armed each of these buildings with a different level of biosecurity. And I'll define that more in a minute, but let's look at them high, you see medium, and you see low up in the upper left corner. Now, notice that these buildings are only about 120 meters or 120 yards apart from the source population. And you can see the directional arrow on the right. Okay, so this is to be our neighborhood. Now, what do we mean by the biosecurity levels? Well, before we started this in 2006, we'd been doing independent work on routes of spread and biosecurity interventions for each of the individual routes of spread. And with graduate students, other practitioners, other investigators around the country, we had identified basically this list of routes that you see in the left-hand column. So we knew the virus could be spread by aerosols. We knew mosquitoes and houseflies could move the virus, so insects. We knew contaminated transport vehicles could move the virus. We knew that fomites like boots and coveralls or containers, semen coolers, product boxes, etc., if they were contaminated on the exterior surface, we know they could pose a risk. And then people. We knew people could carry PRRS virus on their hands, on the palms of their hands after they had handled infected pigs. We knew they could not carry it in their upper respiratory tract based on previous work we'd done. So these were the routes, and we worked individually to develop biosecurity strategies for each of these. And you can see in the high-level facility, we had an intervention in place for all of these routes. We had a filtration system for the air. We had an insect control program. We knew how to properly clean our trucks. We knew how to bring in products safely, and we had shower in, shower out drainage system entry protocols for people that we had validated. So this high-level facility had all of these interventions. It was the Cadillac system. Now, right next to it was the medium level. You can see there that is basically a match, except it doesn't have an air filtration system. Okay, so kind of the industry standard, what a lot of people were trying to do at that time. Filtration systems were not common, but everything else was, but farms were still getting infected. So this was to represent the industry standard. And then finally, the low-level producer. You can see here the producer with no rules, basically. Low-level biosecurity. Anything goes there. You can go from the source barn right into this guy's building. There's no rules. We wanted to make sure that spread would occur in the area. Okay? So this is how we set this up. And remember again that these buildings are centered around this source population. So just to tell you what we learned, very, very quickly to summarize a lot of work that Andrea had led for the first year, and actually throughout the rest of the project, which was a total of 4 years. It was a monster project, but for the first year, the pioneering year, we demonstrated that in that high-level building, nothing happened. I mean, we kept virus out of that building. The pigs never got infected for the entire year. And in that medium security facility, you can see that we did have some infection, but we documented that it was only by aerosol. We actually collected air samples entering the building, found virus, the pigs got infected, and we matched that virus to the source. Okay? And then the low-level biosecurity, you can see that infection occurred frequently, and it occurred by multiple means: insects, contaminated objects, people, and air. Okay? So the take-home from all of this, if we want to take home something big and apply it right away to our farms, I think what we learned from this, and we repeated it throughout the rest of the study, is we understand how PRRS virus can spread between farms. We know the routes. It's a well-documented fact now. Number two, we can prevent infection through application of specific biosecurity protocols, to the point where if we, as we showed in that experiment, if we filtered the air, we could even keep it out for the entire year. And number three, even if you couldn't filter the air, we showed that if you had a medium level of biosecurity as defined by our project, you were better off than doing nothing. So taking care of your trucks, of your people, of your incoming supplies, etc., that was better than doing nothing. It wasn't perfect, but it was better than doing nothing. All right. Well, this one isn't a surprise. And you know, this is an animal welfare issue. It's a human. All right. Well, this one isn't a surprise. And you know, this is an animal welfare issue. It's a human. All right. Well, this one isn't a surprise. And you know, this is an animal welfare issue. It's a human.